In the investigation of any crime, the passage of time is the greatest enemy. Evidence degrades, witnesses vanish, and the trail goes cold. In paleontology, our cases are the coldest on record. The crimes committed millions of years before the first human walked the earth. So how do we find a murder weapon for a crime that is 252 million years old? The trail is not in a fossilized bone, but in the atoms themselves, an invisible fingerprint left at the scene of the planetary crime. Can these atomic clues truly solve the greatest mass extinction in history? Now let's open the geological record and decode the chemical story of this lost world. The case file is for the Permian Triassic extinction, the Great Dying, an event of such totality that it nearly sterilized the planet, wiping out the dominant life forms that had ruled for eons and clearing the way for the age of dinosaurs. Our prime suspect is the Siberian Traps, a volcanic eruption of continental scale. But a suspect, no matter how menacing, must be tied to the crime with physical evidence. That evidence, it turns out, is geochemistry, and the clue is carbon. To understand this clue, we must think on an atomic scale. Carbon is the fundamental building block of life on Earth. But not all carbon atoms are created equal. Like all elements, carbon comes in different versions, or isotopes. Think of them as the same model of a car, but some have a slightly heavier frame. Every carbon atom has 6 protons. That's what makes it carbon. But they can have a different number of neutrons. The 2 most important stable isotopes are carbon-12, with 6 neutrons, and the slightly heavier carbon-13, with 7. Here is the key to the entire investigation. Life has a preference. The chemical reactions of photosynthesis, the process that powers nearly all life, find it energetically easier to grab the lighter carbon-12 atom from the atmosphere. This means that all organic matter, from the plankton in the sea to the vast Permian forests, and even the fossil fuels they eventually become, is enriched in the lighter carbon-12. This creates a distinct biological signature. Life effectively filters the carbon in the environment, hoarding the light isotope and leaving the oceans and atmosphere slightly but measurably heavier in carbon-13. This atomic signature is not lost to time. It is meticulously recorded in the geological ledger. As marine organisms like brachiopods and foraminifera build their shells from calcium carbonate, they lock the isotopic ratio of the seawater at that moment into their own bodies. When they die, their shells sink and become part of the limestone sediment on the ocean floor. Layer by layer, century by century, the rocks build a continuous, high-fidelity recording of the state of the planet's carbon cycle. By drilling cores from these ancient seabeds and analyzing the ratio of carbon-13 to carbon-12, we can read the chemical history of the world. We have our forensic tool. We can now turn to the page in this stone manuscript dated to the end of the Permian period and look for the chemical ghost of the catastrophe. With our forensic tool in hand, we now turn to the geological record itself. The investigation takes us to rock outcrops around the world, from the majestic cliffs of South China to the arid plains of the Karoo Basin in South Africa. At each location, we find the same story, written in the same chemical ink. We drill into the limestone layers that span the Permian Triassic boundary and analyze the carbon isotope ratios, plotting them point by point, century by century. As we do, a clear picture of the ancient world emerges. For millions of years during the late Permian, the graph of the carbon-13 ratio is relatively stable. There are minor fluctuations, the normal breathing of a healthy planetary system. But as we approach the boundary line, the thin seam in the rock that marks the mass extinction, something dramatic happens. The data line plummets. This isn't a gentle slope, it's a sheer cliff. Geochemists call this a negative carbon isotope excursion, and it is one of the most abrupt and severe chemical shifts in the entire geological record. The proportion of heavy carbon-13 in the world's oceans and atmosphere collapsed. It is the chemical equivalent of a scream, a planetary distress signal frozen in stone. To a paleo detective, this sharp negative spike is the smoking gun. Recalling our primary clue, that life preferentially uses the lighter carbon-12, the meaning of this signature becomes terrifyingly clear. The only way to make the entire global carbon cycle so isotopically light, so quickly, is to inject a truly colossal amount of light carbon into the system. The scale of this injection had to be so vast that it overwhelmed the planet's natural buffers, fundamentally altering the chemistry of the air in the oceans. The negative excursion is the definitive fingerprint of a world being poisoned by its own carbon. The next question is obvious. Where did this biblical flood of light carbon come from? The evidence points to a conspiracy of sources, all triggered by a single event. The primary culprit, as we've suspected, was the Siberian traps. The magma didn't just release carbon from the mantle, it burned through massive subterranean coal, oil, and gas deposits. The incineration of these ancient forests and marine organisms released their stored, isotopically light carbon as carbon dioxide and methane directly into the atmosphere. This was the first and largest wave of the assault. This initial volcanic pulse triggered a deadly cascade. The rapid global warming from the volcanic greenhouse gases began to heat the world's oceans. This may have destabilized immense frozen reserves of methane hydrates on the continental shelves. These ice-like structures contain vast amounts of methane, a gas extremely rich in light carbon-12. As they melted, they would have released this methane in a massive burp, further amplifying the warming and driving the carbon signature even more negative. At the same time, this new, warmer, nutrient-rich world created a perfect storm for a biological accomplice. The evidence suggests an explosion in the population of methane-producing microbes like Methanosarcina. Thriving in the suffocating anoxic oceans, these microscopic organisms feasted on dead organic matter, pumping out yet more light methane as a waste product. This biological onslaught added another major wave to the carbon flood. The carbon isotope anomaly is the integrated signal of this entire catastrophe. It is the chemical receipt for a multi-stage planetary crisis. It begins with the signature of the volcanoes, which is then amplified by the signature of melting hydrates, and finally the signature of a biosphere in revolt. The negative excursion doesn't just tell us that something bad happened. It gives us the character and the pace of the crime. A geologically instantaneous injection of carbon so massive that it sent the Earth's climate and life support systems into a fatal runaway spiral. The investigation has led us from the vast Siberian lava fields to the atomic heart of the matter. The negative carbon isotope excursion is the chemical confession of a planet in crisis. It is the definitive forensic link that connects the geological perpetrator, the Siberian traps, to the biological victims in the fossil record. The final step is to demonstrate how this atomic signature translates directly into a global kill mechanism, closing the case on the Great Dying. The colossal injection of light carbon, primarily as carbon dioxide and methane, was not a subtle shift. It was a sledgehammer blow to the Earth's climate system. The immediate consequence, as we have seen, was extreme global warming. But the more insidious effect occurred as this atmospheric carbon dissolved into the oceans. It created carbonic acid, leading to rapid and severe ocean acidification. For the Permian's marine life, this was an existential threat. The very water they lived in became corrosive. The great reefs, the brachiopods, the plankton at the base of the food web, all life forms that built shells from calcium carbonate, found themselves in a world that was actively dissolving them. When we lay the evidence side by side, the correlation is perfect. At the precise geological moment, the carbon isotope signature plummets, the rich and diverse Permian marine fossils vanish. The rock layers that were once teeming with shelled organisms are replaced by a barren extinction layer. The chemical confession of acidification is corroborated by the bodies at the crime scene. Simultaneously, the global warming triggered by the carbon injection suffocated the seas, creating the anoxic dead zones confirmed by the black shales. This chemical fingerprint also explains the devastation on land. The extreme heat and acid rain, direct results of the carbon flood, caused the collapse of entire forest ecosystems. We see this in the fossil record as a fungal spike, a layer dominated by the spores of fungi that feasted on the immense amount of dead and rotting wood. This dead organic matter, rich in light carbon, was now being released back into the environment, further amplifying the initial carbon signature in a devastating feedback loop. The carbon isotope anomaly is therefore the Rosetta Stone of this ancient cold case. It allows us to read the story of the crime from start to finish. It provides the definitive evidence that the Great Dying was a rapid, catastrophic event driven by a massive and violent disruption of the global carbon cycle. The verdict is in. The cause of death for over 90% of life on Earth was acute carbon poisoning on a planetary scale. The carbon atom, the very building block of life, also serves as its most faithful historian, recording moments of both spectacular creation and catastrophic loss. This faint chemical echo from a world long dead offers a profound insight into the delicate balance of the systems that govern our own planet, a silent warning written in stone across the abyss of time.